So welcome back to video number 7. The topic of this video is demand calibration, for which we will use dynamic OD matrix estimation. For our first assignment, we did use a flat demand profile for the AM period from 7 to 9. And in this step, we would like to improve the model by adjusting the demand profile using counts per time interval. So for simplicity, I will explain and demonstrate the steps for the demand segment car only. So now we have link counts for the period from 7:30 to 9 o'clock available in 15 minutes intervals. And our first step is to add these data to the network. And while we do that, we will also produce some further attribute and views that help us to monitor the changes that is created by the matrix estimation, as well as by reassigning the new matrices. So first I would like to add some user-defined attributes. As you have seen, you can do that in the attribute dialog, but you can also do that in the list of attributes. In Visum, we have a list with all the attributes that exist in Visum. And we can also reduce that list to user-defined attributes only. So in this dialog, I will add some attributes for links. And first, I would like to add an attribute that indicates the availability of counts for that link. So I will call that has dynamic count. That is an attribute of type bool. And we will also add a new group for our user-defined attributes, so we can always see them as a group here in the list of attributes. So we can use this column filter and see our newly created attributes. So the second attribute that I will create is the attribute for the counts. That will be called count 15. I will also allocate this attribute to the group. It is an integer attribute. And here I have to make sure that we have the sub attribute analyze time intervals, because the counts are per time interval. And I will also create another attribute to calculate the GEH. So this attribute is called GEH 15. We allocate it to the group, and also this attribute will be available with sub-attribute analyze time interval. It will be a formula attribute where we use the if condition. So we calculate that attribute only if the link has a count. If the link has a count, then we use the GEH statistics. And here we need the volumes of transport system car and vehicles. In order to account for that in the formula, we use this attribute with time intervals. And we add here the counts with the same attribute, sub-attribute. And if the link has no count, we set it to 0. Okay, now we change to the link list. And we see here the attributes for the counts, and now I will read in the count data. I have prepared them as an attribute file, and the counts are then automatically allocated to the corresponding time interval. Now I can filter here my links which have a count. There are no counts available from 7 and to 7:30. And it is also not useful to use counts for calibration here, because at this time the network is not fully loaded, so you might not have realistic volumes that can be compared with counts. So I will remove these columns and add our GAH calculation. For the period from 7:30 to 9 o'clock. This needs to be a floating point number, and we also need to account for that here in the list. Okay, now we have a formula here. That means once we reassign, the formula is automatically updated. But I would like to have a GH value that gives me the starting values, so I need to copy the attribute and make sure that we can keep the initial values which are now calculated. So I duplicate that marked attribute and change the name to init. And then I need to make sure that I have the data attribute and not the formula attribute. And that means I can keep the values as they are now. I will also add this attribute to my list. For the corresponding time intervals. Okay, now I have here the counts, my formula for the GEH calculation, and the values from the current state. And I will also create another display, a link chart, where I would like to compare the counts and the volumes, the totals over all counted links. So for that, I need first to add a filter condition. So I filter links that have a count. And now I will create a column chart. And we'll first choose a title, comparison, volumes versus counts. I then here choose the total volumes, so overall counted links, and that means I will go at the network level to links and use the sum of active links, and then I need the volumes for the transport system car, so the current time interval. And additionally, I will do the same for the counts. So I go to the network level, links, use the sum over active links, and choose the counts for the current interval. Okay. So what I see here now is a comparison over time of the counts and the volumes as they are currently assigned by the by SBA. So what we see here is that in the early time intervals, the counts are much higher. And by using the dynamic matrix estimation, I would like to adjust that in a way that by reassigning the matrices, these two columns match. So in the next step, I need to change the type of my time series, because for dynamic matrix estimation, we cannot use percentage time series, but we can use matrix time series. So I need to convert the percentage time series into a matrix time series. That is quite a simple thing because there is an automatic way to do that. I just click this convert button and then I get 4 matrices. Why do I get 4 matrices? Because my current or my old profile has 4 intervals defined. So now I would like to see that in the matrix list. So you can see here now that we have 4 new matrices, and these matrices have a time definition. And we can also see the current values. I will do that again in order to be able later to compare the matrices with the old matrices. So I need to reassign a percentage time profile, click the convert button again, and get another 4 matrices. So now I can say that this one is my initial flat profile, and that will be my AM profile that will be adjusted by the matrix estimation. So, and now we can see that car is allocated to this demand time series, which means the matrices 9 to 12 are allocated. So that means we keep this one as initial. Maybe we indicate that in the name. And the other 4 matrices is basically what we get after the dynamic OD matrix estimation. So these 4 matrices are adjusted. So the results of the dynamic matrix estimation depend on the inputs. It is the same as for static matrix estimation, and that means the counts should be checked. So counts must reflect demand volumes. So it is not a good practice to use counts that are located close to bottlenecks and are influenced by congestion. And you should also exclude counts where you have an effect of or have an influence from the connectors. So on one side, you need to check counts. On the other side, you need to have reasonable assignment results. So the routes must be realistic and you should not have any unresolved gridlocks in the networks. So these 2 steps are important, but are now skipped in this demonstration. So now we can continue with the procedure sequence. First, we deactivate the existing group and create a new group for the dynamic OD matrix estimation. And it might be good practice that you are able to restore the old matrices. For that, you can create procedure that does exactly that. You can use calculate matrix. And in this procedure, we could, for example, restore the matrices that we would like to change. So that is 9 to 12. And we would like to use the original matrices, which are in matrices 5 to 8. So that is a procedure you might need, but not necessarily. So next we will create the demand matrix correction procedure. We will only use that for cars, and we will use the dynamic matrix estimation. So here we will start with the count volumes. We will use links based on counted link volumes, and our counts are in the network, in the user-defined attribute that we have created. And also here, this indicates that we use dynamic volumes. So as a weight, we will create a new user-defined attribute, which is called ME weight 15. We will allocate that to the group demand Kali. That needs to be a floating point number and has also the sub-attribute analysis time interval. And for that, we use a formula. And namely, that formula will be 1 divided by the square. And here we will use the count values. So according to our experience, the weight should always contain the term 1 divided by the square of the count, because this term leads to an optimization of the GEH value and therefore to a balanced result. If some count locations should have a stronger effect on the calculation, then this value must be multiplied by an appropriate coefficient. So we do not use distribution, and in the configuration there's one parameter quite important, which basically weights either or enters a weight between the influence of the count and the influence of the old matrix values. So we will use a small value, which means that the counts have a high importance here. So the other values we will leave as they are. We will update the allocated demand time series. And then we can duplicate the procedure and move that down after the demand correction. You might run a loop. However, we would always suggest that you monitor the results over the loops. So if you here, for example, choose a stopping criteria that is a network attribute, then you can either base your loop on the stopping criteria. If that doesn't change, you can also make sure that the numbers are predefined. So in that case, you would run 3 loops, and that is predefined. Okay, now I have set up my procedure, and I will now run the demand correction first only. First here the flow matrix is calculated, and then in this progress dialog you will see different outputs. So these outputs is later on also reported in the message window, and you might check that in order to see the changes over the iteration. So you have here the value of the objective function, which goes down. And you have here the deviation for the count values and the change in demand for corrected OD pairs. So once that is finished, you will see the effect in our matrices. So looking at the sums, you can see here that we have now a more profiled matrices, and we will now reassign that. And in my case, I will run the loop as they are and then later on compare the results. So now we have run the loop 3 times. As I mentioned before, it is good practice to check the changes after each iteration to make sure that the changes are in the right direction or that the matrices improve in the desired way. So now you have different possibilities how you can check result. You can of course check the matrices directly and the matrix values by compare the old one with the new one. You can have a look at the GEH values. So here we can, for example, check the maximum. So on this side, you see the GEH maximum after the initial assignment, and now you see the changes after re-estimating matrices. As we can see, that has improved quite a bit. We can also check our chart. So here you can also see that the counts now match the volumes much better than before. So that has also improved in a right way. And then of course it's also again necessary to change different results of the assignment. For example, the statistics of the assignment. So here we can see the gap is okay, has reduced. And you can also check or compare some indicators over from the assignment in the entire network. And of course, then it might be worth having a look at different outputs again if there are some undesired changes in the network. So with this, we are at the end of video number 7, and we will continue with generating subnetworks from a simulation-based assignment.